Good morning, students. Today, before starting the class, I want to request only one thing, that whatever videos I have posted, please go through those videos and note down the notes which I have given in those videos. These notes will surely help you in your coming regular classes. If you have not gone through those notes, you will be having problem in the coming classes, because all these notes are correlated. So again, I request, please go through all the videos which have been posted earlier. Note down the notes somewhere for your future purpose. Now today I'm going to start with the topic, that is equivalent resistance. So the definition of the topic is: combination of resistance is used in many electrical circuits. The use of more components will make an electrical circuit bigger. To keep electrical circuits small and less crowded, it is necessary to use lesser number of components. And on the basis of this, the definition of equivalent resistance is given here. It is a single resistance which can replace any combination of resistances so that the current through the circuit remains the same. So let me explain the definition. So equivalent resistance represents a single resistance. This single resistance will do the same amount of work that has been done by other resistance connected in the circuit. The output of the current through the circuit remains the same. So if you get a single resistance which is going to replace so much resistance, then that single resistance will be known as equivalent resistance. That means a resistance which can perform the same work as it has been performed by many resistance will be known as equivalent resistance. Now moving forward, I am going to take up the next topic, that is series combination of resistance. When two or more resistances are joined end to end so that same current flows through each of them, they are said to be connected in series. Now if you look at the diagram here, I have connected R1, R2, R3, three resistors, one after another, end to end. And look at the diagram here. I is the current which is passing through R1, R2 and R3. So if you have a connection in this format where the components are connected end to end, then this combination will be known as series combination. In this, the same current is flowing through all the resistors. So let me take up the properties of series combination. The current has a single path for its flow, hence same current passes through each resistor. That means all are connected one after another, so the same current I will flow through each of them. Then the point number 2 is the potential difference across the entire circuit is equal to sum of the potential differences across the individual resistors. So if you look at the diagram here, let the potential of the first be V1, other be V2 and the third one is V3. According to the second property, the total potential will be equal to the sum of each of the potential of each resistor. So what is happening in series combination? The same current is passing through all the resistors, but each resistors will have different potential difference across their endpoints. These are the two important properties of series combination. Now moving forward to the derivation of the formula of series combination. I'm going to derive the formula for two resistors in series. Let R1 be and R2 be the resistances connected in series. I be the current through the circuit passing through each resistance, and V1 and V2 be the potential difference across R1 and R2. So if you look at the diagram here, we have got here three things here, and if we take up three things here, I am going to explain for three resistors here now, R1, R2 and R3. The first one is having the potential V1, second one is having the potential of V2, and the third is having the potential of V3. Now according to the Ohm's law, V1 will be equal to IR1, V2 is equal to IR2, V3 is equal to IR3. And as we have seen in the second property, the total potential will be equal to the sum of each potentials. So look at the equation number 1. V will be equal to V1 plus V2 plus V3. Now let R be the equivalent resistance. It means that if I take up a resistance R, which is going to replace all these three resistance R1, R2 and R3, then this R is known as the equivalent resistance. Then the total current I will be passing through R, and on the basis of Ohm's law, I will have the formula V is equal to IR. Now from 1 and 2, equating both of them, I can see IR is equal to IR1 plus IR2 plus IR3. If I take I common, and if I cancel the I on the both the side, I will get the expression as R is equal to R1 plus R2 plus R3. That means if we talk about many resistors in the circuit, then the general formula of the series combination can be given as R is equal to R1 plus R2 plus ... Rn. So if we look at the case of series combination, the equivalent resistance can be obtained by finding the sum of the resistance of each which is connected to the circuit, and the derivation is very important. So look at the derivations one more. We have got the first relation here, V is equal to V1 plus V2 plus V3. We have put the values here, then we have equated 1 and 2 both together. After that we have got the ultimate formula, R is equal to R1 plus R2 plus R3. Now this is the general formula. General formula means a formula which can be used for as many resistors you want to connect in the series combination. Now to make it more illustrated, I am taking one simple example of series combination. Let I take an example where two resistors 4 and 6 ohm are connected. And now suppose we have to find the equivalent resistance of this circuit. So I am going to write the formula first. R is equal to R1 plus R2. Then I am going to connect both of them, and at last look at the answer. It is coming to be 10 ohm. That means if the resistors are connected in series, then the equivalent resistance can be obtained by adding the values of each resistors. Now if you look at this topic here, at this topic, derivation is a very important part along with the properties of series combination. So I request to the students, so go through this video properly, and in the next class I will be explaining some more topic related to this chapter of current. Thank you and have a nice day.